Arithmetic sequences is easier than you think. Arithmetic means you're adding or subtracting to get to the next number, okay? So let's look at this here. Row 1 has 1. Row 2 has 3. Row 3 has 5. Row 4 has 7. Let's fill in the blanks. 3, 8, 5, 7. Without even counting, what do you think the next number is going to be? You're right, it's 9. This is not important. I don't care about the total number of squares because what I care about more is how many are in the next row. And notice we're adding by 2 to get to the next number. That's exactly what we're doing here. This is what's known as an arithmetic sequence. And an arithmetic sequence means you're, again, adding and subtracting to get to to get to the next number. So let's look at this pattern here. Is this arithmetic? Well, let's see. We're adding 13 to every number. So if that's the case, yes, it's arithmetic. If you're adding different numbers, it's not arithmetic. Or subtracting different numbers, it's not arithmetic. Okay, that's important. Well, how is this related to a function? Okay, remember this, okay? It is linear. And the reason why it's linear is because, well, we're basically adding to get to the next number. So you can say your slope is equal to 13 as a matter of fact, okay? So basically, we can say that the function of this, if you want to write it in this way, let's say that when x is 1, it's 26. How about if I go backwards, right? If I go backwards, 26 minus 13, that's 12. So I can basically say, if that's the y-intercept, y equals 13x plus 12, if I want to write it in that context. As we talk about domain, this is discrete because you are counting to get to the next number. You cannot have part of a number, right? So therefore, it's going to be discrete. Right? Remember, discrete means you can count it on your hands. Continuous means you cannot. For example, Chris Guevara, right? Whatever hot dogs he eats, that's discrete because he can count all the hot dogs. Not even part of a hot dog. He's got to eat the entire hot dog, okay? Whereas continuous, the water that he drinks to keep the hot dogs down, well, he can measure in liters and he can have part of a liter. So therefore, that's continuous. That's important. Okay. One thing I want to talk about too is the recursive formula. How we write the recursive formula is this. We're always given a first number. And whatever we're doing from the previous number, we're adding our slope or the common difference. In other words, it's when I write it, it's usually written like this. Okay, the first number, when n is equal to 1, and then you take the previous number and then do something with it when you're finding the second number or more. Now, by looking at this, you can only use this if you want to find the next number. You can't use this if you're finding the 100th number because you got to count 100 times. So if you want to find the 100th number, you got to plug it into here. And this is what's known as the explicit. This is explicit, okay? And we'll talk about how to find the explicit without even writing out the y-intercept and all that stuff, okay? So what is the recursive formula for the height above the ground for the nth step of the pyramid? Well, we're starting, each step is 26, and then we're adding 26 to each one. There you go. That's your recursive, okay? So write a recursive formula to represent the total height. If each stair is 18, well, let's do it real quick. Beep, bop, boof. 18 is the first number. And to get to the next number, we basically add 18. There you go. That's simple. That's it. Explicit, you always have the first number and the common difference. So that's your slope, that's your first number. And you can use it to find any number you want. It does not matter. Does not matter. Okay, let's look at an example. Okay, the cost of renting a bike is shown here. Okay, what is the explicit formula? Well, here's your first number. You're adding 12, boom. There you go. And you can even leave it like this if you want, or if you want to write it in slope-intercept form, that's also fine too. But both are gonna be acceptable. And the reason why we write it in this way is because let's say I want to find the 10th day. I can plug in 10 in for n and then find the answer, right? Whereas in this sequence right here, I got to count 10 times. 18, another 18, another 18. I got to do it 10 times. Imagine doing it 100 times. Whew, have fun. No bueno. Let's look at this example here. Okay. We know it's linear, blah, blah, blah. I'm not gonna bother with this. Okay, the cost to rent a bike is $28 for the first day plus $2 for each day after that. What is the explicit formula? Let's write it out, okay? Remember, it's the first number times whatever number we wanna find times the common difference, n minus 1 times d. This is your d, this is your first number. Let's write the formula. It's 28 plus n minus 1 multiplied by 2. That's it. And if we want to find how much it's going to cost after 8 days, just plug in 8 for n. So 28 plus 8 minus 1 times 2. 28 plus 7 times 2. 14 plus 28, that's going to be 42. So it's going to cost $42. That's it. All there is to it. Okay? Moving on. Absorb it, absorb it. Now we're moving on. Okay, now let's see if we want to go backwards. If we want to go from explicit to recursive, we can identify the first number and the common difference to write the explicit formula. Okay, here's your first number. That's your common difference. Boom, done. Let's do this real quick. Okay, first number is 10. Common difference is -3. Let's write it. Okay, it's going to be 10 plus n minus 1 times -3. Boom, done. Let's do this one. First number is -1. Okay, so plus n minus 1. Actually, am I going to have room? I'm not. So let's write this over here. Let's put it right here. Okay, and equal of -1 plus n minus 1. What's your common difference? 2.4. Boom, done. All there is to it. This one's a little bit different because I want to go from explicit to recursive. So I need to find the first number now. I know my common difference. It's whatever number is next to the end. But to find the first number, I have to plug in 1 into the function. There's your first number for this one, okay? So we know the first number is 3/2, and I'm adding 1/2 to get to the next number. Okay, let's do this one here, okay? We know the common difference. It's 3. Let's find the first number. Okay, 8 plus 3 times 1, that's 11. So if I write out the explicit part of this, the first number is 11. And then to find the next number, I'm adding 3. Voila, that's it. Same thing here. Let's plug in 1 in for this to find the first number. That's 7, okay? So the first number, okay, is 7. And then to find the next number, I'm subtracting 5. Right, because it's -5. There you go. That's all there is to it for this one here. All there is to it, and that concludes the lesson. Again, go through the textbook if you have questions. Other than that, it's doable. Last lesson for the week coming up.